Today, I'm here to talk to you about how I chat with the Berlin Parliament, not the libraries, but the Parliament directly, using LLMs. One of the problems is also because it's extremely boring. So yes, that's my talk today. I'm Stefan Batifol. I'm a developer advocate at Zilliz. Those are my socials if you want to ask me questions later. You can also always find me on LinkedIn, Twitter, everywhere. I'm just going to do a quick sales speech about who we are, and then it's only the fun part, right? So I work for a vector database company. We created Milvus, so it's fully open source. You can check it out online. You can check it out on GitHub. We have a lot of open source products. We have GPT Cache, which you might have used already in the past, and then we have different things. If you don't want to manage anything, cloud offering, the usual, we host everything for you. And otherwise, if you want to suffer like me, like I did today, you go open source, you host everything yourself, and then sometimes you have fun. We have a couple of customers, and I share those because people always ask me like, oh, can you provide things at scale? And so those are some of our customers, so you can figure it out. Then we partner with everyone, AWS, Google Cloud, Azure, data platform as well, GenAI tooling, chip manufacturer as well directly. We have direct collaboration with NVIDIA and Intel to provide vector search with the latest things they manufacture. So like NVIDIA was at GTC, for example, they announced something new. We have vector search on GPUs now. So if you have a lot of money, you can use it, but you need a lot of money because it's very expensive. Anyway, that's it. Today, I'm going to talk about the idea. Why did I do that? I'm going to talk to you about RAG. What does it mean? How do vector database work? Chunking, embeddings. And then I do something which I shouldn't do, but I do a live demo. So let's see. Let's see if it works. I'm very sure it's not going to work for a specific reason, but I'll show you later. All right, the idea. So it comes from a series of tweets that I saw in September 2023, which is from All About Berlin. If you move to Berlin, you probably know this website already, but there was a... No, yes, we're back. They were saying that they had to answer questions from politicians, and one of them was, which services must be digitalized by December 2023 to be in line with the law? So it's 320 services that must be digitalized. The deadline was actually December 2022, and they had digitalized 44. So they were a bit late. And then that basically triggered a thing in my head, which was, oh, actually, they're talking about interesting things. I had no idea. And so then I went on the website, I checked all the PDFs, and I was like, oh, actually, maybe I should learn more about it. So I wanted to interact with it. I'm not going to go through all the PDFs because it's very boring. Also, once you go on the Open Data website, it's very funny. They have a disclaimer, which is saying that due to the file size, it can take up to 1 to 2 minutes to download it. The file is 24 megabytes. They're saying it takes up to 2 minutes. So that's already a big problem. Then every time you click on the link, they generate the XML file, and it takes up to 30 seconds. The file changes every day, once, but they generate it every time. So if you want to DDoS the website, you can just download it, the XML file, and then they will DDoS themselves for you. Enough about them. The problems, though, that is extremely boring to read. I'm sorry, but it's like one file, they have all the information about who's asking the question, different things. It's in German, which is not a problem. The problem is like it's in politician German. So that's like very wow. And then they don't have any search. So you have to go through all the documents to find something. The name of the document is like S04-19, which is not very useful, right? To know what they're talking about. So those are the problems. So when you have problems, you use AI. It's 2024, so you use RAG. Does anyone doesn't know what RAG is? Perfect. No, it's fine. It's fine. I work in it, so then I'm like, yeah. But some people don't. I'm gonna explain, so no worries. So it means retrieval augmented generation. And the basic idea is that you have your data, you have an LLM, large language model, you want to use your data with this large language model. How it works, it's going to come back. Yes, it came back. How it works is that you inject your data via a vector database. like Melvis, if you want to. And then you have your query, you have your LLM and your embeddings, and then you have your vector database, and you have your data. You put your data in your vector database. You do your query, transform it into embeddings, similarity search, and then suddenly you have some results. And then you're happy, or not, but at least you know you have something that is a bit more interesting, which is browsing PDFs. You can use it for different use cases, factorial recall, forced data injection, cost optimization as well, because the LLMs are quite expensive. So yeah, as a takeaway, use RAG if you want to use your LLM, if you want to force your LLM to use your data, sorry. And then how do vector database work? You probably have heard about vector database a lot of time in the past 6 months because everyone created their own vector database, so everyone is then selling it. But how it works is that you have some documents, you put your documents through deep learning models, and then at the end, right before you do the softmax, you cut it short, then you have vectors, those are your vectors. You store them in a vector database, and that's what you use, that's what you have, that's how you have dense vectors. And then you can do like a lot of search and you can use them and then you're happy. And that's basically how you create vectors. That's how you have them everywhere now. And then vector databases are very nice. People sometimes ask me, why do I need one? Why can I not use like, I don't know, Face or anything first? It's like, in general, and not only Milvus, but like vector databases, they just store things, index and relate entities by like quantitative value, and they do it in a very efficient manner. Also, there's the vector similarity, which you have like, then it gives you a measure of how close things, of how close two vectors are. And then, yeah, you have like similarity metrics. And I won't go into details because you can find usually on the internet. And then like, if I tell you all the metrics, then I don't even remember myself all the metrics. So it depends, but you have some similarity metrics, which are ways to measure distance in the vector space. It goes back to like university or even high school. But yeah. So then vector database for RAG, again, it provides the ability to inject your data via semantic similarity. So we're back to what we were doing, you know, like 15 years ago, 20 years ago for information retrieval. It's the same. We have semantic similarity, but now it's just cool. And yeah, you just have to take some things into consideration when you do it. You know, like it's not only about RAG or whatever. You have to be like, okay, how does it work at scale? What is the performance? What's the flexibility? On our side, when people ask me like, oh, why should we go for you? Or like, what do you provide? The thing we do is that first, we're cloud native, we're fully distributed by default. We have true separation of concerns. Those are the things that actually I like. That's why I joined the company. Because I was like, yeah, cloud native. I used to work in the Kubernetes world where everything is like distributed, everything is like, you suffer a bit, but then you're happy, you know, when it works. Basically, it's the same. You suffer a bit, but it scales. So yeah, that's a differentiation. Why you shouldn't maybe use a SQL or NoSQL database, it just depends. I'm not going to go through the whole list, but vector operations are quite intensive computationally. So then they might struggle for that. They might not have the right indexes. They might not have, you know, have thought about different things. So that's why you may want to use a vector database. So yeah, Populibus to handle indexing, storing, querying your data. We handle billion plus scales. I'm not saying that as like, we just throw a number. We have clients with 10 billion plus scale. Once actually came once and they were like, we have 5 trillions. Can you handle it? The answer is no. But if hello again. Yes. If you're not at trillion scale, maybe we can help. Anyway, back to my RAG, back to chunking. So chunking is something you really have to take into consideration, when you do RAG. And you have to take into consideration the chunk size, the chunk overlap, and then character splitters. So chunking is like, you have your text, you're gonna divide your text into like different parts, you know, and then you really have to take into consideration the size, but also how does your data look? Is it conversation data? Documentation data? Is it a lecture? Is it a Q&A data? Like for lecture, for example, it might be easy for you to separate things. You might have teacher, double dash, and then student. And then you might want to chunk that way, you know, might want to chunk it like, oh yeah, please take the teacher, please take the student. Same for Q&A. You might have Q for question, A for answer. Documentation, what might be useful is that if you might want to chunk like the title of the section, you might want to show like subtitles, and then you add those basically to your chunk, and then it's going to provide better results. Conversation, it's a bit different, but I won't go over that. And if you're wondering what it looks like, this is with the data that I'm using. So that's the data of the Berlin Parliament. That's chunk size of 32 characters with an overlap of 10. You can clearly see that, there's like nothing really relevant in here. You just like text, and then text is what I added. And then everything in German is from the Berlin Parliament, but you can really see there's nothing valuable. You won't have anything really good from that. Then you can also have a bigger chunk size. This is with a chunk size 128 with an overlap of 20. You can see we start to have like better sentences, have better context. You might be able to tell what people are talking about. It's still not amazing. And if you don't speak German, no worries. They basically don't say anything here. And then bigger chunk size, so 246 with an overlap of 50. You can see like now you start to have like some real sentences. You can like, figure out what they're talking about. And that's very useful because it's the same for your LLM basically. If they can't, like if the chunk size is too small, they're just not being able to, tell anything, which they're like, yeah, what are you talking about? I have no idea. So that's like very, very important. On my side, for the demo that I have, I used Llama Index. Llama Index, and I'm sorry for the people in the back, you probably can't see anything. But Llama Index has a sentence splitter, and they allow you to basically chunk in a smart way, or they try to. They try to keep the paragraphs together. They try to keep the same text together. And that's really, really helpful because then everything is dynamic. You can see the first chunk is like 2 lines, then the second one is like, I don't know, 6, 7 lines, and the third one is even longer. And that way it allows you to keep the context, and that's usually very useful. So takeaway, it just depends. Honestly, there's no good way or bad way. It just depends on what your data looks like and what you need from it. Unfortunately, for now, there's no magic, there's no secret, just to play with things. Then you have the other thing that people sometimes talk about, sometimes they forget. It's embeddings. And it's the same for embeddings. You have to pick a model, you have to know what to embed, and you have to check your metadata. And again, there's no like, this is the embedding you should pick. It really depends on the context, so you have to play again, and you have to have fun. You have to look at all the models. They have way more models than that. And then depending on your need, like you're really gonna go for maybe OpenAI embeddings if you have something that is very generic. For this demo, I go for Gina AI because they have a really good embedding models from English and German. So the text can be in English or can be in German. The questions can be in English, can be in German, and they provide embeddings for both languages then. So then you can do, you're able to be like to ask something in English even though the text is in German. OpenAI is not as good with that. You'll see during the demo if it works. And then you might want to have like other embeddings for like specific use cases. Like I know, not Mistral, but I know another one which is called embedding like croissant or something, which is good for French. Depends on your language. You might want to choose embeddings. There's also on Hugging Face. You can see there's a whole ranking. So if you want to have like the best at something in particular, you might want to go there, but it really depends on your use case. You also have different strategies because otherwise it wouldn't be fun. So you can like embed your chunks directly, what we saw before. You can embed sub and super chunks, sorry. And then you can also try to incorporate chunking and non-chunking metadata, which might be able to give your LLM more context and might make it more helpful in the end. And like example of metadata for chunking, you have paragraph position, section header, larger paragraph, sentence numbers. And for non-chunking, it's going to be like author, publisher, organization, like those other things that might be very useful actually in the end, and then also those are the ones that are like really useful when you search for something and you're like asking for the source. They're going to be like, oh yeah, that I found it. And then they look in the metadata and they're like, oh yeah, this is the PDF number 22, this is page 3. And that's how they can tell you the source, for example. And now it's demo time. And let me tell you, I'm going to show you that, which you should be able to see. Yes. And before, I'm not going to spoil it actually. So I'm just going to walk you over what I did. How is it in the back? Should I zoom more? It's fine? Okay, cool. So you install your dependencies. We don't care. That's like boring. And then you can see how dirty I am. Then on my side, so I'm using Milvis, which is the vector database company. You just instance it. Then you have your all different collections. You're very happy. You don't know the data. We don't care about that as well. And then I'm loading everything. And as I said, I'm using GenAI embeddings. So I'm just going to be like, OK, please give me the GenAI embeddings. I'm going for the English-German ones, which is this one. I also have OpenAI embeddings when I was doing test. And I just didn't want to remove it, basically. Then I have the different LLMs where I am saying, hey, please let me use GPT 3.5 with a 16K context length. And then I'm going to define everything with like my LLM, my embeddings, the chunk size I'm using. And then I'm being like, hey, have my Milvus vector store, create a collection with like embeddings, which are like specific dimension, which is depending on your embedding model. And this I put false because this afternoon I put true. So then I lost all my data when I did this demo this afternoon. So I made sure to put false. So I actually have some data now. Then you ingest the documents. I'm not going to do that because it takes a long time. It takes like about an hour. But then, yeah, I'm not sharing my screen fully. Let me go back to them. Wait. That's a whiteboard. Cool. Okay, I'm just going to go that way. Anyway, so then I have my database here, and we're happy. And I have my embeddings, and like everything has been here. And you can see I have about 72,000 in there, and now my database is not working, so that's fantastic. Told you I shouldn't do demos. As a DevRel, you very rarely do demos. People tell you all the time, don't do demos, they don't work. But I'm going to try something. Give me 1 second. Let's see if it works. But the idea is that I have my collections, and yes, I am back online. Woo. So I have my data, and you can see just like you have an ID, then you have your embeddings, and then in the dynamic fields, you have like all the metadata that I added. So you can see, okay, like the page label is 38, the file name is, P19004, whatever. And you have like all those metadata which are for you not useful, but they might be very useful if you want to ask for, the source or something. So that's what it looks like, basically, once you do your embeddings and then you put them in your document, in your vector database, sorry. Yes, those are the embeddings of the chunks. So those are after, yes. Yeah, it's like, I created the chunks before that I showed, and then go through the embedding models, and then you have that. And then here I'm saying, please use a retriever. That's it. So I'm just going to use the Milvus as a vector database, and then we're going to go. And then we're here where my agent is created now. So I'm using the OpenAI agent, and I'm going to go for this one. And this is the part which is very fun, which is I tried to go for scale this afternoon. So I was like a bit tired of the demo where you have like, I don't know, 100 examples. I wanted to go for millions. OpenAI disagreed with me. So they rate limited me. So no, I can't use OpenAI. And I couldn't use it at like 6:30 p.m. So we're going to check if OpenAI allows me now. But they have a rate limit, and they were like, no. Yeah, and I'm still rate limited. So that's cool. Oh, you don't see. Thank you very much. Because I was not sharing my own screen. Okay, we're back here. Now you can see. Yes. So you have, again, OpenAI agent. I created. And then I'm going for like the one with Milvus, OpenAI, and GenAI. And again, here, you can see, I'm trying to talk to my OpenAI LLM. They're like, nope, you've been rate limited because I've played a bit too much with it this afternoon. So that's the annoying part. But as a backup, can I just share my whole screen? No. It's a bit annoying, but it's fine. As a backup, I'm sorry for always switching then. So I have here my terminal. And basically, I'm just going to show you what's happening when you do RAG. Like it does that in the background as that. So I'm going for my GenAI embeddings. Yes. Here. Is it good? Okay. So my input, which is in English, is does the Berlin Parliament requires fax machines? And basically I'm going through that, and then it replies with that. And that's like it replies with the model, and then it replies with the embeddings, which is what I'm interested in. And I need to pick them, yes. So here I just gonna select all my embeddings, which is after it's converted by Gen AI. I have to stop sharing my screen. It's a bit annoying, but we'll make it work. And then I go to I'm back to my database where you have all the embeddings working. And I'm just gonna go on my collection and I'm gonna do a vector search. I'm gonna do it the very old way. I'm just gonna copy paste the embeddings that I just got. Can I zoom in? Yes. That I just got from Gen AI. And I'm just gonna copy paste those embeddings. Then just searching, well, it took like 300 milliseconds in my whole thing. And it's telling me, okay, this ID has like the highest score. And this is where you probably have something about fax machines. So I have to actually check the file name, which is S1914497. And again, I have to stop sharing my screen. And I'm just going to open it. Yes. And we have, yeah. This is the PDF that was suggested. And indeed, it is about fax machines. And that's if OpenAI didn't ban me, then you would have had this information directly from the LLM, because then you go to vector database, then inject it into the LLM. And indeed, it's about that. And basically, that's it. I have one more thing to show you, but I have to stop sharing my screen again and start again. Go back here. So yeah. My demo was supposed to be better if OpenAI hadn't rate limited me, but I had to find a backup. But then I have a question for you, which is, how many services require the use of fax machines in Berlin? But you have to tell me a number. 323. 3.4 million, that's a lot of fax machines. That's a lot of services, sorry. So 44. All of them. All of them minus 44, so it's 320 minus 44 then. Okay. When I'm not banned, those are the answers I get. So OpenAI is on the left. OpenAI loves to talk, as you can see. And it's like, this document, blah, 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 blah. There are like at least 3 specific services require the use of fax machines. And then they're just going to tell you the services. Gen AI on the right side is way more concise. And they're saying there's a total of 189 services that require the use of fax machines. It is actually 189. So it's not only 3. So yeah, as of today, or as of September, there were 189 services that require the use of fax machines. And that's how I found out through the RAG and through using then the correct embeddings, because then OpenAI couldn't do it, or couldn't do it with the way I've done it, whereas Gen AI could do it. So that's also like to keep in mind, chunk embeddings is very, very important. It is correct, it's on the PDF, but I would show it, but then I have to stop sharing again and then start again. So. But I can show you it's in the PDF. And yeah, OpenAI is like then confused. Is like, oh, they don't talk about that at all, like in any document. Sorry, yes. Yes, it is actually explicitly stated. No, exactly. It's just me asking the like stupid question, and then they actually found it. Whereas OpenAI is really struggling. This one is the classic. I forgot the name, but the classic one. Yes. And the other one is specialized in German English. Yeah, the question as well. No, I mean, it's also probably because of my chunks and different things, but then it's also because OpenAI is really, really good in English, whereas all the documents are in German. So it can also like, struggle to actually find that and find the 889. Yeah, it found the document, but then it couldn't be like, oh no, I can't find it. And that's it. I'll organize a meetup next week. If you want to join, you can come. Put me on Discord. You can give us a star on GitHub. So then my manager is very happy, and then I can give all the talks. That's it. Thank you. Any questions? Yes. Should we give the microphones to people? It's for the recording.
Maybe I have a question first. Did you try to sell this to the Berlin Parliament or work with them or something, or just?
Yeah, that's the thing. I'm not sure I'm like strong enough mentally. So.
Just to continue on the joke, the last AI event I've been to, AI Tinkerers, had 15 presentations. 2 of them were about digitalizing or dealing with the German bureaucracy. So it's a running theme. It's also just interesting that we use AI to deal with fax machines. 2 questions. Yes. One mainly about the RAG. So I'm CTO of a startup. We're building a startup here, not really in Berlin, but I'm currently in Berlin. Those are all supplementary details. I've been searching or choosing the vector database. It didn't turn out to be Melvius, I'm sorry.
It's fine.
But in that process, of course, there's like so much to compare. There's so many different benchmarks or different versions. I would just like to have your 2 cents on that. Like, how would you, if you would build a startup, compare vector databases? How would you go about that? And so that's the first question. And then second question for the chunking. It's a never-ending issue. Beyond brute force, just chunking different versions and testing which one works best, do you know a better way to deal with that? Of course, there's some libraries you can use, but what would you recommend?
I'll go for the first one. So before working at Zilliz, I was working for Volt, the food delivery company you have everywhere. And my job, I built the machine learning platform there. So I kind of went through that on like comparing things. And the way I did it and the way I would do it now is depending on like, do you need open source or not? Do you want to have open source or not? It's really like, that's the first thing. Then I would go for like different SDKs. Does it have different SDKs? Is it like, does it support streaming, for example, because you might have streaming data and different things. Then does it scale? But does it scale in a way that is not biased? Because we all say we are scale. So then it's like, looking at different benchmarks. And if I go now, and I'm going to do it live, it's going on this website, which is fully independent and benchmarks, and then have a look. I think depending on like the distance and stuff, we are usually above, like in there. Like for example, Mirvis is here, and Glass is our cloud offering. So that's like, I would look at benchmarks, but like we have benchmarks. If I go on a website, we have benchmarks. But if I was not working there, I wouldn't trust them. So then I would just look at independent benchmarks. And then, yeah, just really depend on like how you're gonna deploy it. Do you want to manage it or not? Like our whole ML platform was on Kubernetes. It's still on Kubernetes at Volt. So then I would look for something that also works on Kubernetes, like to fully integrate it with the rest of our stack. Basically, that's how I would go. Second question with regards to chunking. On my side, what I liked was Llama Index chunking sentence, which is here, sentence splitter. And yeah, it splits documents into smaller chunks. Try to understand it, try to make something out of it. Because yeah, I didn't want to go through like the 320 or like, depending on the task and stuff. Like look at different libraries like that.
Sorry, the question was more about how to tune the hype parameters.
How to
tune the hype parameters in this particular use case.
So, for this one, yeah, honestly, I just brute force and try, and like I don't think there's any library so far. I haven't found any.
Thank you.
Yes, of course. You're back.
Anyone else has
There was a question on the right side.
Okay, brute forcing is not a good way for that. So are there any libraries or custom code you would advise to evaluate that yourself?
Then on my side, it's like trying to, first I would like do some chunks also per paragraph, and then like do some sub chunks. So like you have smaller chunks that are maybe like 350 characters or something. And then I'm trying to incorporate as well what's above or what's, like with the overlap. And then I'm also going to try to incorporate like the title if I have a document with like a lot of titles. And then it's just about like having all those metadata. So then it's like very useful, but otherwise I'm just brute forcing at the moment. So. the Berlin Library person.
Yeah, just not a question, just something to support your assessment of Jina and OpenAI embeddings. We tried for, I wouldn't say weeks, but for a pretty long time to get the chat bot to understand the German word Roman. Ich möchte einen Roman. And OpenAI embeddings always, or OpenAI turned this always into Roman. So we weren't successful. So actually the solution was to translate the German question into English, get the answer from OpenAI in English, and then translate it back. And then it worked very well.
Yeah, it's usually
so OpenAI really sucks in German, I have to say.
And if you want to talk more about Jina AI, the head of research, he's going to talk about embeddings at the meetup next week. And he's fantastic. He's so smart.
Where, what, how, what, where?
The meetup, if you scan on the right side, it's at Get Your Guide next week. Jina AI, head of research, is going to talk there about actually how they build the embeddings and everything.
Cool, thank you.
Yeah, cool.
All right, so no more questions.
There's one in the back, but I don't know.
We'll be a bit mindful about the time. So if anyone else has questions, you can find Stefan after, right?
Yes.
Perfect.
Yes. Thank you.
By the way, I just want to remind you about the draw prize thing. So if you did not do that if you want.
Hello, everyone. Oh, sorry. Hello. There we go. Okay. Hey. Sorry about that. It's always like this. I'm Kristian from the Vespa team. First of all, thanks to the AI camp, Joanna and staff for organizing this. Very much appreciate it. Also, thanks to Stefan for a great presentation. I was smiling a little bit because we always get rate limited. That happened to me last time too. So this time I'm running a local model. First of all, some intro. Let's see. Yes, why is it not sharing? All right. All right, okay. Now we're sharing the right window. I always share my inbox. My boss hates me for that. So I'm Kristian. I'm from the Vespa team. We've been on this for more than 20 years as a search and recommendation platform. So we come from it from a slightly different angle than Stefan and the others. We started more than 20 years ago as a search engine. Building on recommendation cases a bit after that. We open sourced 7 years ago. And in this presentation, I will be using the open source Vespa. We also have a cloud offering since 2021, just like Stefan and the others, where you don't have to bother, running it yourself. These are some of our users. Some are known to you, and there are lots of others too. And this is the team. So I don't look like I come from a startup, right? I'm probably one of the old ones here. But we started as a separate company last year in Trondheim, Norway. And as I said, we're hiring. We have the dev team in Trondheim, and we are hiring sales and marketing elsewhere. So I think I'll complement Stefan's presentation a little. We are at it at a different angle. Some of the questions people have, there's a lot of FOMO out there, fear of missing out, with all these new tools. So I'll try to do a more practical walkthrough of what we did last year with respect to RAG. And I'm not an ML engineer, so I don't know much of that. But this is important. Generative AI can go very wrong, and it has financial consequences. So getting this right is both difficult and important. And Air Canada learned it the hard way. Their chatbot promised customers things it shouldn't. So we'll just do a quick intro about what large language models are. It's like they are generative models. They make things. I think of a model, say the large language models, as kind of a lossy compression of the internet. If you think of it that way, it's like Mistral that I'm using here is like a 4 gig download. I can ask it a lot of stuff, and it's sometimes very stupid, but it's also sometimes very smart. So it generates things. So they're good at that. So you can use them. Some call it autocomplete on steroids. This is from LLM Studio, by the way. Quick questions. How many of you have downloaded a model and run it on your laptop? One. Oh, great. LLM Studio, Olama. Okay, cool. Yeah, if the sharing works, I'll try to do some Olama stuff. So we'll go through a case where we did summarization. Prompting is, how many have you heard about prompting? Yeah, those are instructions, and I hate it because it's, I'm a developer, and I think like writing text to a system to tell it how to behave is very, very wrong. So recommendation, look at the SPI for a more programmatic approach to how to prompt the large language model. Yeah. So one of the problems with models is that they are old. You know this, they were trained months ago, and it's very hard to update them, if any, and it's very expensive. So the zip file I talked about, the compressed internet, it's already dated. So that's one problem, and that's what RAG is trying to address. It can have a lot of data it shouldn't, and if it has, you can't really get it out. And it hallucinates. It says wrong things, just like in the Air Canada case. So that's another problem with large language models. So now I was trying to do a demo, but I'll just skip to the output of it. I'm going to Paris tomorrow for the same talk. So I figured let's ask my local Olama model. This runs on my Mac, about French restaurants in Berlin. So how many of these restaurants do you think exist? There's one, the number 5. It's in Paris, and I'm going there on Friday. It's totally wrong. It looks very, very nice, but it makes no sense. Right. So the problem is it looks so impressive. It's like, but if I'm following my own advice, I'll be very skinny for the next meetup here because these places don't exist. So this is a high-level overview of what RAG is. So Stefan talked a lot about this part. This is where you put your content and you query it. And you can query it by using vector operations, but you can also do a lot of other stuff. Based on your content, you have the prompt, which is your updated data, and then you query your language model. So why did I put client here? It's a server, right? So what you will find is that you have many options. Like you can use OpenAI API, but you can also use a local model. And you will see that a lot of the innovation is going to be on the models. It's like every day you can download new models from Hugging Face. So what I want you to do is to build such a system that you can run in your environment and configure the clients to go to OpenAI or your local model or whatnot to get acquainted with how this works. So in my case, sorry. So it's as simple as this. A lot of you have Olama. Run it in a Docker container with a name. So you have an endpoint on your laptop. Then you can use, in our case, I used Vespa. But you can use other things too. And you can have your content here. And you will access the local model on a Docker network. So this is all you need to run a RAG on your laptop. So let's see if I'm able to share another window. All right. All right, okay, that didn't work. I'm sorry about that. Okay, I'm going back to the presentation. My point is that, yeah, let me go back. Let's go here. So as Stefan said, you can set up a vector database to store your data, figure out how to embed the data, and write code, and you're done. And that's almost true. We talked about the chunking. He's very right, but it's also cases where you have much more control of your content. So the chunks are kind of, what's important for your application is that you're writing for the LLM. So you define what's in a chunk, and what's in a chunk should be a logical unit that can create a meaningful embedding. So what we found is that if you create things that users will query for, those are good chunks. So you can look at it that way. Right, I'll just skip this. Let's try another demo. Nice. This worked. So this is our RAG prototype from last year. So what I'm showing here is what we try in the Vespa team to help you help yourselves when you're using Vespa. We have lots of documentation, and it's an open source project, and people can't find what they're searching for. So we get a lot of support requests. So we built this system based on our documentation. It's not very big. So this is a regular search. So in the RAG case here, we extract the results, send them to OpenAI, and ask for a summary. So in this case, we decided the chunk strategy to be linkable units in our documentation. And we simplified it as simple as if it has a header, everything between headers or rows in tables. So this works extremely well. People can just paste this into the config and it just works. So that's the normal RAG case, but we wanted this part to be the center of the experience because this is the actual documentation. This is a helper part. This is something that you can be aware of. If you put this center and this as a side note, then it could be wrong and it will mislead users. So we worked very hard to have the LLM link into our documentation and guide our users here. I think that is one thing that you can take away from your RAG implementation. Another thing that can improve your RAG is this. So you see the suggestions there? If you guide your users to write better queries, the RAG will work better. It's as easy as that because you can control what you guide the users to. So how do you think we made this? Any ideas? So we used an LLM. So for each of our chunks, we queried OpenAI. What is the best question for this piece of content? So we just processed all of our documentation and we annotated all our pages with the most likely good questions. So that's an offline processing using an LLM. So by this, we kind of offloaded the work in advance to help users find the things because, oh, I'm looking for this one. And this is already annotated to one of our chunks. We thought we were very clever about this. Having good suggestions is very critical for your applications. There is also some other things. We couldn't do this by embeddings only. There are a lot of text signals in there and substrings and so on. So I'll go away from this one. Yeah, that's my backup slide. Okay, the context for the generative model, I think both me and I, Stefan, covered. My key point is that to extract that context, you need both the similarity, but for your structured content, you also need to add signals like filtering on attributes like location or time, or is the restaurant open? Could be a very good thing to filter on. So we suggest that it will be a combination of similarity and other signals in that mix. So you need some system to do that. And we often get this question, is Vespa a vector database? And the answer to that is we added support for tensors 5-6 years ago, I think. Tensor is a multi-dimensional data structure, and the vector is a small tensor. And we added approximate nearest neighbor search 3 years ago with HNSW indexing, which is more or less the industry standard in indexing. So you can do vector operations in Vespa in addition to all the other signals for matching. In addition to that, you also have a lot of ranking functions, so you can plug your own models to do the ranking, because you could be matching 100,000 restaurants. So you need a way to rank them too, because you're only interested in top K. I think I'll just skip this. Yeah. But the realization is that you're not writing for the end user, you're writing for the machine. This is an example of our prompt. I'll just skip over that. Suggestions. Yeah, this is just our documentation in Markdown. This is like you see the chunks here. This is what we extracted. You feed it, and this is how we tagged each of the chunks with the most likely queries that are LLM generated. So of course, when you start typing and you select this one, you will have an extremely good match. It's identical. This one? We didn't spend much time or sophistication on this. And that's the problem with prompting. I think it's very, unscientific. It's like you're hacking away and next week it changed. So I hope this goes away very, very soon. Your instructions? Yeah. Right, right. Helpful factual answer. Okay, so this is how you see where you store the different data. So you can have the different signals where you have textual data that you can embed combined with all the filters. One thing that you should be cautious about or think about is that a document will have lots of embeddings, right? So last year and maybe before, the normal way was to just create the chunks and index them as separate units. We think that if your unit is the page or the conversation or an item, it's much better to have an array of embeddings. So in this case, where you have array of strings, this will be converted to arrays of embeddings like this. So we'll just iterate over the array elements, embed it, and feed it into Vespa. So you will have a max function. So you do the similarity over the best item in the array. That will make your application a lot easier if you're extracting pages, not chunks. Yeah, this is just too complicated to go through, but this is just a copy from our configuration, which means it's a combination of the semantic scoring, which is the similarity, and text signals that will improve the quality of the data you retrieve from your local database that you feed into the large language model. I think we need a follow-up on this anyway. It's just too complicated to go through this. But it also says that this is just mathematics. This is just tensor operations you see here. Okay, so there are many, many things that Stefan and I didn't talk about. Those are the hard problems. It says like this is going to cost a lot if you don't take care. That is because it's very easy to explode your data set into large vectors for really high precision. So a lot of the industry is now working on how can you, with low precision vectors eliminate most of the data set and spend the GPU and CPU on the high precision vectors. I'll have some links at the end of the presentation with some reading for you. But there is a lot of research into how you can reduce dimensionality to just focus on the most important ones, and how you can quantize, so you don't need to use floats, but you can use bits. Like a bit is 1/32 of a float, and use Hamming distance, which is a really CPU low operation. So those are things we didn't cover that we really should talk about. We should talk about how can you put some or most of your data on disk, which is cheap, and what needs to go in memory. How you can do the multi-phase ranking on the high precision vectors, and using a very complex ranking function for high quality data there. So I think we'll just leave those questions for a possible. Would you be interested in learning more about that? A few of you, yeah. It's to me. Matthias asked me, "What are you most excited about?" And where are you? Yeah, there you are. And I think that the way we are transforming our problems into the numeric domain is like vectors and tensors, and making them independent of modality, language, image, text, videos, audio, those kind of things will really change the way we write our applications. So getting into tensors and how we work on them, I think will be very, very important. These I'll just put in the Slack, the AI Camp Slack. I'll see you there, or you can just grab me on LinkedIn, and we can continue. But these are some of the most recent posts I really like, and that you should read as follow-ups to this. And of course, shameless plug for our own blog. That is also a good way to learn. We also have a newsletter and some Twitter handles. And let me know if I should come back for to go more into details of this. Yes, okay. Then I'll take questions.
I saw that you handle metadata. When it comes to metadata search, is it filtering or is it doing a BM25 kind of search on that?
So that's a great question, because a search is multi-phases. The first phase is what we call the phase 0, which is the matching and some ranking part. It depends on which operator that you're using. But we can simplify and say the first phase is the matching, is like excluding everything that doesn't match. With vectors, everything match. It's just a different distance. So you have to put some threshold. But if you are using, say, a BM25, which is a text search algorithm, then you can have some scoring and just drop everything with 0 or below a threshold. In Vespa, you will have the matching phase, and then you will have first and second phase ranking. So in the first phase ranking, you can say, do a BM25 and a threshold on the scoring. And then you can add a vector similarity signal as well. And that's a very common pattern. And then you can do a second phase ranking. And a lot of teams are now looking into doing that with a model like Colbert and those kind of things. Or you can do homebrew rank functions. It's like homemade, but using a very expensive model on, say, 100 or top K results. So multi-phase ranking, and in the last phase, you normally retrieve the high precision vectors if you have them. But that's an awesome question. I was hoping for that.
What else? Okay.
Hi. One quick question for clarification and then maybe follow up. You've spoken about the popularity ranker that is based on the retrieval popularity, or what exactly did it mean?
So you decide yourself what your signals are in Vespa. We don't do anything. We just provide you a toolkit. So if you say you have an attribute in a document, say, this thing is more popular than other things, it's just a numeric score. And you can use that in your rank function.
Popular relative to the users.
Well, it's up to you. Things can be generally more popular irrespective of the query. You have query independent. Say you have you're doing a web search. Some sites are better than others. Spam sites are 0. If you have Spiegel or some other high-profile sites, you can give them a high score irrespective of the query. Or you can write functions where you have parameters from the query and you have multipliers and those things. I hope I answered your questions. So you can rank with both numeric attributes or text matching signals in the rank functions.
To rephrase, is it dynamic? Does the popularity or the weight at that point change with usage, or does it only change based on my in the beginning? Do I set it in the beginning, or does it change dynamically?
You can always update any element in Vespa per document. You can also do what we call a global. Say you have a group of documents, say a site. So you can have a global score for the site that each child document will import. So that's one way of doing it. So you just update it once. You can also pass it with a query and say that, well, now I'll use this value instead of the one stored with the document.
Okay, thank you.
I think there was a person.
How do you evaluate the results, like final results and the retrieval results? Do you have any framework?
So normally you can use the track eval. A lot of teams do that, which is a good tool to evaluate if you have a ground truth, to see how your scoring function works. That's also good when you're training your models for ranking. Say, in here you can have a huge GPT model if you want to, if you have trained it. And to do the training, you need to export all the ranking signals from Vespa. In the Vespa platform, we don't have those tools. We just recommend people to use the generic tools.
Thank you.
It's also a great question because people should be very concerned about their quality and how you measure it.
Okay, anyone, one last question? Okay.
Awesome, thank you. I hope to be back sometime.
Thank you.
My German is so bad, it only works after 2 beers. So I'll start the first one now and I'll see how it goes. Thank you.
Thank you. So we will have a 5 minutes break. So we do refreshments, anyone, toilet, whatever, and then we'll come back.
Test.
Hey everyone, let's come. All right, the stage is yours.
Yeah, thank you very much. Hi everyone, my name is Thomas. I'm from CLOUDETEER. CLOUDETEER is a cloud native. Meanwhile, grown up, not startup, from Hamburg. We also have an office here in Berlin for security, data science, AI, landing zone, migrations. Again? Closer, very close. Okay, and yep, this talk is, we will just put aside a bit LLMs. We will do also AI, but we look from another perspective, from the perspective of the infrastructure within an AI system and how we can boost those infrastructure to boost AI in the end. Yeah, that is what the topic is about. And there's one new specific role arising, the AI engineer. You heard it for several times in the media. And okay, what exactly is this? We have data scientists, data engineers, ML engineers, and so on. What the fuck is AI engineer? Yeah. What is the skill set of an AI engineer? What is the toolkit, open source toolkit to work every day to be successful? And during the last years in different industries, in chemicals, electronics, energy, logistics, and so on, I discovered some best practices which are valid even today. Yeah? And I want just to share with you. Maybe you can use it for your projects. Okay. The three on the top, that was when I was studying data science and doing AI. Yeah? We have a data engineer in the back end, we're building pipeline for data, delivering the data science team, we're doing the magic. Yeah? And on the other side, on the front end, we have the data analyst building super cool reports, yeah, for stakeholders, finding solution for business problems and so on. And then somehow they're crystallized an ML engineer bringing data science to production. Yeah? And also the business scientist is another buzzword existing right now. Yeah, the data scientist with a strong business focus to solve problems in the business. And now we have somewhere an AI engineer. Yeah? What exactly is that? You can shrink some of the old worlds together, you can split it up, or you can put it somewhere in between. I don't really have a clear answer, but I think it's depending on the project, on the role, on the customer, on the skills you are working on. Yeah. Yeah, at least to be an AI engineer, you have to know all of this. This is very mad. It's a machine learning, artificial intelligence data landscape, which is updated every year by Matt Truck. Yeah, and this is a cool overview because you have on the left side infrastructure, the analytics, machine learning part, all the applications. And down here in the orange field, that is something what attracts us, what is we like to do, yeah, all the open source stuff. So you can see the landscape is turning very, very fast. And in the past, this mad landscape was updated yearly. Last year it was updated for 4 times. Yeah, so it's going crazy. And what was the landscape in 2012? Is anyone here finding him or herself back in this mad summer with software tool stack? You have? No. Maybe R? Maybe R, yeah. Yeah, this is a dinosaur. Yeah, it's still existent. I found some for me. It's in the middle, statistical computing. When I do my bachelor's in Kiel in economics, we did some regressions with MATLAB, and it was crazy, you know. But after doing this, I know I can do everything in my life. This is good. So this is the landscape, and I will just pick out again the open source tools usually used today in different projects. And yeah, so you cannot know all. Yeah, only Chuck Norris can, or the special one, Jose Mourinho or so. Yeah, so I try to pick off my best 5 op in the next slide. But before, we're going through some skill sets from the technical side and from the soft skill side. Yeah. So the first good AI engineer have to know is what programming language. One programming language he deeply understands. Yeah, this is hard. Yeah, this is where the power lies and the magic. And it's also machine learning. Because the center core of an AI engineer somehow is data science. Yeah. And software engineering, analytics, big data, backend, Gen AI, XAI. What is XAI? Explainable AI, and that is one of the maybe most valuable and important skills in the future. Yeah, we have more and more apps, more and more AI, and somehow have to explain it to someone. What is happening in that black box? And we will need tools who can do this automated for us. Yeah, not only defining the metrics and calculating the metrics, but also communicate the results of the metrics to customers. And that is where LLMs come in. Seems cool. Yeah, this is how I started reading Introduction to Statistical Learning to understand the basic concept of machine learning. And it's even today, yeah, the best recommendation I can give to every data science student to read this book. This is like understanding the fundamental concepts. Yeah, and later on, starting programming and everything around it. And yeah, and I felt like this little boy there. But now, since last year, you got this book translated into Python. Yeah? You don't need to learn R again. Yeah? You can just start with Python. You can download via PDF or wait until August this year for the hardcover for 74 euros. So, yeah. Okay, my top five. Open source tools are number 1, Python, scikit-learn, TensorFlow, Pandas, all the cool stuff where the matching happens. And it is also get the version control. You must be able to work in feature branches and dev branches. Yeah, you must be able to modularize your code. That is important. And Docker. You have to transport your application to other systems with all your dependencies on your environment that can work on every operating system. So that's very, I think we saw some Docker or Kubernetes back there, yeah. And yeah, GitHub for the team collaboration, but also for using GitHub Copilot for coding, and the Spark framework for parallel processing of big data. And for example, Databricks is built on Spark, and you can also use PySpark. So that are my top 5 skills where I can manage 90% all projects. So now I will take you to some former projects at customer side to show you what have I done in the past and what I would do now with LLMs or with the new technical stuff. This was a project in the chemical industries where our customer called us and said, hey, we have some rest budget. It was middle of October. We have some rest budget for the rest of the year. You have time to Christmas or a week before Christmas, so 7 weeks. I say, oh, yeah, that's great. Yeah, what do you want? Yeah, we want to do some, we have a cloud, word cloud or some colored points showing which safety labels or product labels are similar and which not. Cool. And how many? 6,000. Oh, cool. Yeah, but you have to wait 4 weeks to get them. But I can give you 5 now. And yeah, that is the dream of every data scientist, to start with very few, very less data to begin programming. And what I did was just parsing PDFs. Now, very blindly, I just have some weeks time and never did NLP in my life before, and I had to do a course, a 2-day course for another team. And I just parse it. I use the word-to-vec model from Kranzkowski to tokenize and vectorize the data. Yeah, and it was, I think it was in 2020. And last year I realized, oh, whoa, I think I did something like a vector database. Yeah, and then after that you see here, there's a big array, high dimensionality. You can use dimensionality reductions like TS&E to break it down and to make it more visible. You can use CRS score, cosine similarity, so 1 minus cosine distance to do some similarity analysis, and on the clustering of it on it. And in the end, you see a wonderful picture of all the safety product labels and see in which region for which herbicide, fungicides, and so on, they are very similar. Yeah, now we've heard in the other 2 talks before, we have some very, very cool tools to put some vector database. Yeah, and also some which are open source like doc array or vector flow. So I've linked them here. I hope you will get the presentation after the talk. And there's another use case in logistics to write an algorithm or write code for routing optimization. And it was the same case. Okay, where's the data? I don't have any data to do it, but I have a lot of constraints for the code. And okay. And yeah, today with LLMs, that is very easy to use, or just use LLMs for generating synthetic data for your data science project. To test your model, to evaluate your model, to make it run. And yeah, what I did, I had luck. I was working with location data, geopoints, floats, so I can use NumPy random to create some. Yeah, and but for text, it wouldn't be so easy. And today you have like libraries like GenSynthesizer and PyDBGen, or just use LLMs. Another case is customizing your CLIs, like your Linux command. Yeah, you can put your variables, your commands directly with the argparse into your CLI command. And this is very cool because when you build different models and want to pass parameters and argument like down, box, batch size, learning rate, and so on, you do not have to go always back into your main pie, to configure all the parameters. You do it just there, and you do it somewhere in a config file. Yeah, you store somewhere a config file, put your parameters in there, and run and stuff. Explainable AI, yeah. At a big energy enterprise, I was asked to evaluate or build a pipeline, evaluation pipeline for email classification. It were around 80 classes that were built. And there was a third-party AI doing the classification. And I only had the API endpoint to get the responses, yeah, to put in a golden set label and get back as a result and create some metrics like precision recall F1 score. And you know, it was a very traditional company where most of them were between end of 40 and middle of 50s. And then you come there with the mid of 20, end of 20, and want to tell them what to do because we need it for this AI. They were like, difficult, you know, when it's so easy to convince them that you need help, like labeling a golden data set for your evaluations. But in the end, it was good learning to how to explain complex things very simple to them that they can understand. Yeah, you cannot just say a precision recall 2 positives divided by false positives plus 2 negatives or something. You cannot do it. You have to speak in clearly whole sentences that they understand what the model is doing. Yeah, and you can do it automatically using libraries like Alibi Explain or Explainer dashboards. See, you run just one command, put your model in its success set, and you got some fancy results. It goes very quick. Don't have to use much, but you can also build your own models, your own packages for the evaluation. And feeding it with LLMs for a text output that you can transfer or communicate to the stakeholder. And another cool stuff using Python are SDKs in a cloud environment. Azure, AWS, Google Cloud, they all provide software development kits that can scale automatically, are elastic. And so if you can use it, use them. And when I want to go back to the Docker thing, I want to say a lot of you working with Docker. Yeah. So it's always the same. Keep your images as small as possible. Yeah. You don't want to blow up the whale. Yeah. And yeah, this is you always have to be careful on thinking about, okay, which side packages in your environment you pack into a Docker image you really want to use and you need to use, and which not. So take only that in your container what you need. Anyone heard of open source security? Yeah. Good. This is security is one maybe, yeah, how to say, be sure your AI application is secured. Yeah, this is fundamentally important for our safety. When you think of your autonomous driving, I don't want to sit in the car knowing that any packages can be attacked or somehow breached. So at least you don't have to be an expert in OSS. You just have to know the basics, and you have to understand. Okay, when you're using like OSS audit, scanning your requirements, your dependencies, and you got vulnerabilities in it. Yeah, look for them. Look for the versions. What is the score? Yeah, it's critical, it's medium, low, high. And if it's higher or critical, then look for another version. Change your version and deploy the model again of the application. In best case, you run a deployment that checks it automatically. Yeah, so if any critical thing appears, thing will never be deployed. Yeah, it will just stop. Yeah, so there's a whole package of skills for an AI engineer. It's not the technical thing, it's also understanding the whole business problem. How do you want to create an AI if you don't understand what the customer really needs and what the solution of the problem is? Yeah, and you have to be able to design a solution. You have to use DOA architectures, with concept board or DOA.io, communicate it to non-text, develop it, test it, deploy the system, develop again, and so on, optimize, monitor and explain the results, and then take action. Yeah. So here for the end, yeah, AI can be very critical since future, but as long as we take care of our code and make sure that it's secure, and from an ethical side, it's correct, I think we don't have to worry. Yeah. So, thank you very much. Yeah.
All right, thank you. So, any questions? No questions.
You mentioned open source security. Is it what GitHub is doing, for example, or like open source projects and stuff? You know,
it's also, but you can also use like open source libraries like OSS Audit. There exist many. Find the best one suiting for you, and put it into infrastructure. Yeah, and let do the checks.
Again, going to security. So you talked about the packages, dependencies, open source. What about the you talked about Docker using Docker as well. What about the Docker images security?
The Docker image security itself, I don't know, because it would be checked before the images will be built, yeah, and deployed. Yeah, we put your requirements to build the image and then run it later as a container. But you can make sure that your dependencies will be checked before you ever build the image and deploy it.
Sorry, about the registries security, like where do you keep the Docker images, like in the registry? How would you take care of this?
Yeah, you can, on this topic, I was working with a DevOps expert together to do this. But it was a project in Azure DevOps. And I will find out for you I can't remember, some years ago.
Thank you. I'm just curious about.
But you can do it. Yeah.
Thank you.
I propose to end the evening on a less serious question. So when I joined data science back then, I remember the recruiters couldn't differentiate between data analysts, data engineers, and data scientists. Basically, every description was a mashup of everything, and they would disagree with themselves. How do we explain what you just explained, what the AI engineer is supposed to be, to especially the HR community? I think they're going to have a problem.
Yeah. It's a good question, and it's very hard. You can say the AI engineer and the AI engineer alone on a project, working from the end-to-end project with all the roles. Yeah. But I would think an AI engineer is software development skilled data scientist with strong data engineering background.
How does that differ from machine learning engineer?
Machine learning engineer, machine learning engineer, yeah. Yeah. I think you.
Actually, a good question.
I think there comes maybe the business understanding on top. If you want to create the system, you have to understand the business. Cannot create a system.
Just one word on that. Maybe it could be that AI engineer is seen maybe as also kind of like a full stack, but only for AI.
Yeah,
and it's like
yeah, there can be full stack ML engineers. Yeah, this is looking like it's really full stack, and there's no one size fits all. That is absolutely not possible. Also, I do many projects really alone and somehow manage it, but I wish to have like colleagues, yeah, with expertise in a specific field, yeah, to be just more productive and faster and